Alright, so in this video we're still talking about rewriting roots in their power form, but we're going to introduce a few more rules. Okay, so again, we're talking about real roots. In the previous video we talked about this. N is called the index, and to rewrite it in the power form, the index just goes on the bottom of our fraction. Now, if n is even, this is important, if n, our index, is even, then we have two nth roots, and they're going to be what's called real numbers. For instance, if I take the square root of 4, then it has two real roots. I should say plus or minus 2. Positive 2 is a root, and negative 2 is a root. Because when we undo square root, we're going to do square. Square and square root undo each other. So I could say negative 2 squared is 4, and 2 squared is 4. Both of those get me back to the number that was underneath my root symbol. Okay, so if my index is even, whether that's a 2, a 4, a 6, a 100, whatever your index is, if it's even, you're going to have two roots, plus or minus. Don't forget that. Super important. Okay? If n is odd, you're only going to have one root. Okay? So don't really worry about this here. This is just saying the root of 0 is always 0. And here, a few more properties. So here I have n as my index, and I have a power of m on the outside. Well, I can rewrite that as n is my index, so it goes on the bottom of our fraction. My power that's on the outside is going to go on top of the fraction. So just a quick example. Let's suppose I had 2 to the 4th, and then I want to take the square root of that. So again, for square root, the index is 2. So I had something like this. The square root of 2 to the 4th power. So that 4 is up in the air. I can rewrite that as 2 to the 4 over 2 power. Okay? Pretty easy. Let's do another example now. Suppose I had the cubed root of x squared. Well, you can rewrite that as, again, your index goes on the bottom of your fraction, and then your power goes on top. So the cubed root of x squared can be rewritten as x to the 2/3 power. The index is always going to go on the bottom. And same thing here. This might seem familiar to you. If you have a negative power, you want to think of it as bunk beds. Okay, so for instance, if I have x to the negative 2 power, that's the same thing as saying, all right, well, x is not happy in the top bunk. Imagine bunk beds, brother and sister, and they fight. This kid's not happy in the top bunk because he's got a negative power. So to make him be quiet and quit fussing, we're going to put him on the bottom bunk. As soon as he's where he wants to be, he gets a positive power. He's happy, nothing's left on top, so I'm just going to put a 1. Let's do another example. Let's suppose I have 2 to the negative 3/2 power. Well, 2 is automatically starts in the top bunk, and he's got a negative 3/2 power. He's not happy in the top bunk, so I'm going to flip him to the bottom bunk, 2 to the 3/2 power. He's happy on the bottom, so he gets a positive power. Nothing's left up top, so we just put a 1. Okay? And then finally, an example. Now that we know some of these extra properties, we can solve this equation. 2x to the 4th equals 162. First thing you want to do when you're solving this type of equation is you want to get your x, whatever it is, x to the 4th in this case, you want to get that by itself. So my first step to get x to the 4th by itself is going to be divided by 2. So I have x to the 4th equals 162 divided by 2. Okay, so I believe that's 81, but I'm just going to double check it in my calculator. So 162 divided by 2 was 81. Okay, now my power is even. Okay, so I have 4th power. To undo the 4th power, I need the 4th root. To undo 3rd power, I would need the 3rd root. Okay, so what I'm going to do in this particular problem, undo 4th power, I need the 4th root. Well, 4 and 4, they cancel out, so I'm just left with x. But notice here, my index for the 4th root is even. So I'm going to have two answers. Again, two answers just means we put plus or minus, and it's the fourth root of 81. Well, I don't know what fourth root of 81 is off the top of my head. So I'm going to do some scratch work. I can rewrite that as a power. It's 81 to the 1/4 power. Well, I can type that in my calculator very easily. So 81 raised to the 1/4 power. Remember, when you do a fraction in your calculator, it has to be put in parentheses. So I get 3. The calculator is only going to give you one answer, but just remember the rule. It's an even root, so you need 2 answers. So plus or minus 3 is my answer here. And you can verify this by graphing. I'm going to just go in y1, y2, like we've done in class a couple of times now. I'm going to type my original problem, 2x to the 4th equals 81. Graph it, and every time I do a new problem, I'm going to zoom 6. Now, 81, I don't see my points of intersection, so I'm going to zoom out. Still don't see my points of intersection, so I'm going to zoom out again. And now, there's my points of intersection. I should have 2 points of intersection, because if you remember that original picture of the graph, it looked like a U shape. So I'm going to have an answer over here on the left, an answer over here on the right. So second calc, option 5, first curve you just hit enter, second curve you just hit enter. I'm going to find the one on the left. I don't know exactly where it's at, but I'm going to guess somewhere over here on the left. And I get x equals negative 2.52. Over here, and the reason why I'm not getting the correct answer is because I typed in my y2 was incorrect. It should be 162 here. That's my fault. So let's just start the problem over. Sometimes that happens. Zoom 6, zoom out again, zoom out again. Just keep zooming out until you see that point of intersection again. It made that U shape, so I should have 2 points of intersection. The second calc, option 5, first curve enter, second curve enter. Yes. So x equals negative 3. Exactly what we wanted to find when we did it by graphing. Okay, find the other one, second calc, option 5, first curve enter, second curve enter. Yes. X equals positive 3. So again, I just kind of backed up what I was saying, is that this is supposed to have 2 solutions because our index was even. Okay? And that's it for this video.